we're going to see how to approach a limit, how we're going to approach in finding a limit or in evaluate a limit. We have the limit as x approaches a of f of x. The first is to try doing direct substitution, and we can have mainly three options, or we have a form like the limit as x approaches a of f of x is equal to b. So probably here we are done if we find a number. If we have the limit as x approaches a of f of x is equal to some number, let's say b, divided by 0, probably we are dealing with a asymptote. Maybe there is not much to manipulate, and probably we are done, and it means that there is a asymptote in could be towards infinity, and so we are done. We don't need to manipulate anymore usually. The other option is to have the limit as x approaches a of f of f of x. After doing the substitution, we got 0 divided by 0. This is a indeterminate form because we don't know what's 0 over 0. Indeterminate form, not to be confused with indefined or undefined form. The undefined limit is when the limit goes to infinity, or you could say that is undefined because it goes towards infinity, or that is unbounded. But don't confuse undefined with indeterminate form. The indeterminate form is because we cannot evaluate it due to 0 divided by 0. So when we have 0 divided by 0, we need to do mainly three things. We will try to rewrite the limit as a something that we can factorize. Let's say we have x squared minus 4 divided by x minus 2, the limit as x approaches 2. So what's this? Direct substitution, 4 minus 4, 0 divided by 0. So here what we try to do, we rewrite this as x minus 2 times x plus 2 divided by x minus 2. Now we take the limit as x approaches 2, and we got 4. So first step is, if you see something like this or some polynomial divided by other polynomial, you try to factorize. The other is, if you have here something like, let's say the limit as x approaches a of whatever, something, a root, let's say x as h approaches 2 of x, I don't know, minus 4 of x squared minus 4 divided by let's say a square root of 4, or square root of 1 minus x squared, something like this. Here, if we try to do this substitution, we'll have 4 minus 4, it will be 0, and here will be 1 minus 4. No, well, here will be 4 thirds. Well, here we don't need to rewrite the thing, and we got in this category. This we find it. Well, anyway, it's difficult to think in one as I do the video, but when we have a function something divided by something and there is a root inside, you can conjugate and multiply by the conjugate of the root. If the root is here, let's say something like, let's a minus square root of b or a being some function of x, whatever, and here c, whatever, you multiply by a plus root of b, or vice versa if the root is here, whatever. This would be conjugation. If you have roots, you usually try to rewrite the indeterminate form as conjugation. And if you have trigonometric identities, like let's say that here you have the limit as x approaches pi over 2 of, let's say, secant of x divided by cosine of x. Here, evaluating both, we have 0 divided by 0. But if we try to rewrite this thing as cosine of x is equal to, let's say, square root of 1 minus square sine of x, we would have secant of x divided by 1 minus square sine of x, and so, here we have again 0 divided by 0. Alright, maybe this is not the best example, but sometimes you can rewrite this. Usually is when you have a 2 in some way. That is when you can rewrite as 2 cosine of 2 cosine square of x minus 1 equals to cosine of 2x, or you have 2 cosine of x sine of x equals to square sine of x. So you usually will try to use the identity angles in that way. And here maybe this wasn't the good example, but that in the problems that you be taking and you have trigonometric functions, if you try to change the way in how you write this, could be by Pythagorean theorem or trigonometric identities in identical angles, you will see that you probably will find the limit. And if you cannot rewrite in any of these 3 forms, you try to approximate using the graphicator. And like that, you will approach the limit. You would not find the limit, but you will approach the limit. So in this case, direct substitution, you find the limit. Direct substitution, and you got a asymptote. That doesn't mean that you find the limit because it's a asymptote. Here in indeterminate form, you rewrite the thing, and in any one of these, you do again direct substitution, and you find the limit. If you did not rewrite this, because you cannot rewrite this, you do the graphicator, and with that you will not find the limit, but you will approximate to the limit.